Hello, today I'm gonna solve find the minimum in rotated sorted array to number 154. Okay, let's read the problem. Suppose an array sorted in ascending order is rotated at some pivot unknown to you beforehand. For example, there is an array 0, 1, 2, 4, 5, 6, 7 might become 4, 5, 6, 7, 0, 1, 2. Find the minimum element. The array may contain duplicates. The first example, array 135, the output is 1. And the second example, input is 22201, the output should be 0. Note that this is a follow problem to find the minimum in a rotated sorted array. Would you allow duplicates to affect the runtime complexity? How and why? Okay, let's think about the idea to solve this problem. This is my personal idea, which is a little bit different from classical binary search algorithm, but basically it also performs log and time complexity, same as binary search algorithm. Okay, let's see the nums array in the picture, and the mean point exists among the array. So how can you find mean point as fast as log and time complexity? I simply thought about the jumping mechanism increasing exponentially, plus 1, plus 2, plus 4, plus 8, and plus 16. It's increased twice every time. And if we notice that it passed the mean value, we decrease the jumping distance half of its previous one, so minus 8 and minus 4 to move back to the mean point. To implement this movement, we have to manage several parameters. The first is offset, representing the current jumping length, so it will be increased to 1, 2, 4, 8 at each step. And we have to remember the current position, because the next position is from the current position plus current offset. And we also have to know the current move has passed the mean point. If past flag is true, we have to move in opposite direction by setting direction flag -1. So the next position would be current position plus offset. And also we have to multiply direction flag about offset value. By doing this, we can go back if we have passed the mean value. And the offset value would be managed like this. If past flag is false, we can increase the offset by twice. Or if past flag is true, we have to decrease the offset by dividing by 2. But offset value should not be 0. So in that case, we just set one value. In other case, we can set the offset as it is, which is the calculation value, by dividing by 2. So let's think about the detection of passing mean value during the movement. How can I know that? The first way is to compare the previous value and the next value on its position. So let's think about this pattern. This is the sorted and rotated array, and the mean value exists here. So when we pass the mean value during the movement, we can compare the previous position value and the next position value. So we could see that the next position value is smaller than before. In that case, we could know that the mean value should exist between them. So we can set direction flag -1 and pass as true. Let's see the second example. In this case, the numbers are flat, which are same value, except 1, which would be the mean value. So when we compare the previous and next values, they are same. So in this case, we cannot assure the mean value exists between them. So we have to check by searching all values between previous and next. During the iteration, if a smaller value exists, that shall be the mean value. And let's think about the third pattern. This is the simply increase the array. In this case, the past flag is always false, and the position reaches the last index. In this case, the starting point would be the mean value. Okay, let's see the solution. I implemented the find mean function. As I already explained, there are position variable, and next offset and direction flags are declared here, and the past flag set first, and the previous value and mean value are initialized with the first element. In this while loop, the exponential movement are implemented. The next position is calculated by current position plus offset multiply direction, and the next position should be in the boundary of last index. Mean value is updated always with a smaller one. And this part is the detection for the first pattern. So it compares the previous value and the next value. So the next value is smaller than the previous one. We could know that it has passed the minimum value. So set the direction flag -1. In vice versa, which is the opposite case, the previous value is smaller than the current one. In that case, we should go forward again. So set the direction flag 1. But past flag is not changed, because once it has passed the mean value, we should decrease the offset exponentially. This code increases the offset value twice if it has not passed the mean value, and decrease the offset value in half if it has passed the mean value, but offset value could not be 0. This part is to detect the second pattern. So if previous value and the current value are same, we should check the mean value exists between them. If we found the mean value, we update the mean value and break the while loop immediately, because we don't need to find anymore. And this condition is to detect if it reaches the mean point in the first pattern. So if it's already passed the mean value and the offset reaches 1, we can assume that it already reaches the mean value in the first pattern by moving forward and back behavior. And this condition is to detect the third pattern. So the next index reaches the last index, but it's not past the mean value. In this case, it's a steady increased pattern. So we could know that the starting point is the mean value. So finally, returns the mean value. Okay, this code performs 4 milliseconds, which is faster than the 98.49%. Thank you for watching. See you next time. Bye bye.